Uh, Guys, we have this problem now, and they say this system is unstationary. If this system is unstationary, guys, and they say to you, what is Fnet? What is Fnet of this system? What is Fnet? What are you gonna say? The system is unstationary. Remember, when a system is unstationary, guys, Fnet is equals to 0. And when the system moves with a constant velocity, Fnet is also equals to 0. So in this case, it's unstationary, and now they start to apply a 15 Newton force to this object. They pull it down, they pull it vertically downwards, and they apply a force of 15 Newton. 15 Newton. So when they do apply this force, now the system starts to move, and it accelerates with an acceleration of 1.2 meters per second per second. So now the system, it has an acceleration of 1.2 meters per second. Now the question comes and they say to you, calculate the frictional force experienced by this system, and also determine the coefficient of friction that is experienced by this 10 kg block. Not this one. They want you to calculate the frictional force that is experienced by this 10 kg block, because now this surface here is a rough surface. So we know we have friction when an object moves on a rough surface or a rough plane. So now it has friction, but this one it doesn't have friction because they're using a frictionless pulley. This is a frictionless pulley, so it doesn't experience friction. So now they want us to calculate frictional force experienced by this 10 kg block. So what is it that you're gonna do? First thing you need to know, follow these steps. Whenever you come across this kind of questions, you must follow these steps. You need to determine all the forces that acts on this 10 kg block, and also determine all the forces that acts on 2 kg block. So let us go ahead and identify our forces. So this is a 10 kg block. Let us take out all the forces that is experienced by this 10 kg block. What do we have now? We have this force, which is tension on the string. And we know that tension is always acting away from the system or away from the object. Tension is always acting away from the object. So now in this case, tension, it goes in our eastern direction, which is our positive direction, because I'm taking the direction where the system is going to as my positive direction, and then where my friction is going, I will take that direction as negative. So now let us take out the forces that acts on this 10 kg block. What forces what forces can you take out from this 10 kg block? What forces is this 10 kg block experience? So I will say that we have frictional force, which is there. We have a frictional force, and we have tension, of course, and we also have weight, guys, because now this object, it has mass, and we have weight now. We have weight, Wg, and now we know that whenever there is weight, there will be a normal force, because normal force is always acting at the right angle to the surface. It's equal but opposite to our weight, you know. It's equal but opposite to our weight. This is normal force. Let me move this one. Let me write it here. This is acceleration that our system experience when I pull down this 2 kg block. When I pull this 2 kg block, it pulls this 10 kg block because they are connected with the string. So it will cause this one to accelerate because there is a change in velocity. So now we have normal force here. So we have 4 forces that this 10 kg experience. So we're done with this one. Let us take out all the forces that 2 kg block experience. We have tension. This is tension. It's acting away from the object. This is tension. And now we have force applied, which is 15. We have let me just write force out. Let me just write it like this. So we also have weight, because now it goes down, and we know that the gravitational acceleration, it always pulls everything down. So this, it has weight, guys. So we also put in that weight here. So now we see this one, it has 3 forces that act on it. This one, it has 4 forces. So after this is step 1. Step 1, you draw your free body diagram, and your next step is calculating your weight for both objects, for both blocks. So let us calculate a weight for this 10 kg block. What is our weight? 10 times 9.8. 10 times 9.8 is 98 Newton. So we have weight. So we have to calculate weight for this one too. It will be 2 kg times 9.2. This is 19.6 Newton. So now we have our weight, So we're gonna use our formula. F net is equals to the sum of the forces. That is Newton's second law. F net is equals to sum of the forces acting horizontally on this object, this 10 kg object. And now we also do the same for this one, for 2 kg block. Is equals to the sum of the forces acting vertically, because these forces act vertically on this object. So F net, we know F net is equals to MA. So MA, what is all the forces acting on this 10 kg block? We have remember, we take T as positive because we take our eastward side as a positive side. So now this is gonna be T here, and then our friction will be minus friction because it's going in an opposite direction. Then this is Fk. So now we substitute here. What is our mass? Mass is 10. Then what is your acceleration? Your acceleration is 1.2. What is your T? You don't have T. And then minus friction, we don't have friction. This is 12. This is my equation 1. So I'm gonna create another equation using a 2 kg block. Let us go and this is step number 2. This is step number 2. This is step number 1. Step number 1, you determine the forces, drawing your free body diagram, and you calculate your weight. Now step number 2, now you formulate your equations. So we formulate an equation for 10 kg block, and we formulate equation for 2 kg block. So now this is MA. What is forces acting on this? We also have weight. We also have weight. So we have FA, which is applied force, is positive because it's going to our positive side, which is where the system is going. So now we have weight because we have to add this together because they're going to the same direction. So it's FA plus WG minus tension, because now tension is going in an opposite direction to our F applied and weight or tension. So now let us go and substitute here. What is our M? Is 2 here. 2 times A is 1.2, which is our acceleration. They gave us our acceleration is 1.2. So what is this? Two times 1.2. 2 times 1.2 is 2.4. Is 2.4. FA is 15, and then FG is 19.6. 19.6 minus T. We have to add these ones. 15 plus 19.6. There is 34. 34.6 minus T. So now you can see here, guys, on this second equation, we will be left with T is equals to something. So now let us take T to this side and take this one 2.4 to this side so that it can be subtracted from this 34.6. So our T is equals to 34.6 minus 2.4. 34.6 minus 2.4 is 32. 32.2 is 32.2. So now that we got 32.2, we will have to take that tension and substitute it on our. This is our equation 2, by the way. Because now we got this, it's equation 2. So we substitute equation 2 to substitute. It's either you use elimination method or substitution method. But now in this case, you see, we only have T. We can't use elimination method. There is nothing that we want to eliminate. We just want to substitute our T so that we can get our FK. Because the question here is to calculate frictional force and find a coefficient of friction. So now we substitute 2 in 2. We substitute 2 in 1. So this is our equation 1. So we substitute this equation here. So where we see T, we put in 32.2. I will substitute after this, guys. So we put in 32.2 minus FK. So now I will do the same here because this is negative. I will take this one to this side and this one to that side. FK is equals to 32.2 minus 12. 32.2 minus 12 is 20, guys. This is 20.2. The correct answer is this one. So Mapakati, the one that I sent you, I saw my mistake. It was here. I didn't use a calculator, so I got 4.4. I don't know where I got 4.4 from, but I used the calculator today, so now it's 2.4, the correct answer here. So now it will lead us to get 32.2, because on the picture that I sent you, you saw that my tension, it was 30 point something. So this is the correct answer here. So now the final answer, they want us to calculate coefficient of friction. So we're gonna use our formula for coefficient of friction to calculate coefficient of friction. Let me erase this one. So coefficient of friction, this is the formula. So now they want this, we have this. For 10 kg block, FK, we have 20.2 divided by our weight, which is 92. 98, which is 98, guys. It's 98, not 92. So, what is 20.2 divided by 98? Yeah, still it is still 0.2 now, 0.21. On that picture I sent you, Mapakati, I got 2.4. So now, because of that issue here, I solved it. Now this is the right answer. It's 2.1, the coefficient of friction, and it doesn't have SI unit. So I hope now you understand. Mapakati, this is for you, man. All the way from KZA. This is for you, man. Mapakati, I'm helping you, so help me, to find other students. I need support. Tell them to follow me, hey? Thanks, hey? Bye-bye.